know how I got the points for 1 and 2. Any guesses? Any predictions?
Yes, I know how you did it.
How?
I would not say
You plugged it
anything.
in.
What do you mean I plugged it in?
You plugged in the points for X and Y.
So, I will agree with part of that in the sense that every point on this red line should do what to this red equation?
Make it true.
Make it true. However, I will say guessing and checking every single point, it takes a lot of time. But there is a way to do kind of what you're talking about with that, Kelsey. What's a mathematical representation that would allow me to organize all of the points that make the equation true? What is a mathematical representation that would allow me to organize a table, right? And remember, X, your input, those are the independent variables. Those are the things that you can choose on your own and plug it in. What's the next value that I could plug in?
7.
I could do 7, but it's not usually where I start.
3.
1, 0.
Personally, I always start at 0. It's literally in the middle. So I start at least with a line, and I will say it changes when you deal with other types of functions, but I start with 0 for a line, and then I do 1 and 2, -1 and -2. That's it. If I plug -2 in here, y is equal to,
Listen to my back.
let's focus on the math.
I'm sorry.
If I plug in -2 in here, y is equal to, if I plug a -2 in here, y is equal to, thank you. If I plug a -1 in here, y is equal to, so if I plug in a 0 for x,
0.
1, 2,
3.
so no 0, 0, 1, 1, 2, 2, -1, -1, -1, -2.
Yep.
Notice I could have plugged in a 7. You're right about that, Peyton. But I'm going to do a few points around the y-axis first.
Hey, you asked, I just said 7.
No, I agree with you.
7's just 7, you know.
I agree. I'm just pointing out the fact that I would usually start with that 0. Because first off, I want you to notice, what do we call the output when the input is 0?
7. The output and the input is 0.
It's where we cross the y-axis.
Intercept.
Y-intercept. Notice how that gives me my y-intercept right away.
Yep.
And then what is my rate of change?
I mean, it should intercept at all points, shouldn't it?
It's not going to intercept the y-axis at all points. It's only going to intercept the y-axis when the input is 0.
What are you laughing at?
Kelsey's struggling back there.
What?
Alright, moving forward though, so that we can focus on learning today. We have our y-intercept here to start, right? But what is the rate of change? What is happening to get to each sequential number?
Wait, why can't it be 2, 2 then?
What do you mean?
Why can't 1 be 2, 2?
Well, 1 is not 2, 2, but I think you're trying to ask a different question that I'm not understanding what you're asking.
Why can't it equal 2, 2?
Why can't what equal 2, 2?
Because if x equals 2, then y's got to equal 2, so
Yeah.
why can't that equal...
That is
A
a
point.
point.
But it's not the point of interception. Gotcha. No.
Well, and that's not what we're looking at right now, and it's not that. But I'm just trying to point out this fact. When I create the table, I can see my y-intercept. It's the output when the input is 0.
How did you get your rate of change for that?
Because remember, I plugged in my -2, I plugged in my -1, I plugged in my 0, 1, and 2. And those are the outputs, right?
Mm-hmm.
Now, what I'm trying to point out is the rate of change. What is happening to get to each number,
It's going up by 1.
right?
Yes.
And if we're repeatedly adding, what mathematical operation is that?
Multiplication.
Okay? And don't forget, what is this form of the equation of a line? Y equals mx plus b, the slope, intercept. What would have to be understood to be being multiplied by this x?
Y.
1.
1, right?
Which is...
What is the multiplicative identity?
1 and 0.
Well, 0 is the additive identity, multiplicative identity is 1.
Right.
So notice we're multiplying by 1 here. And what am I repeatedly adding by?
1.
1. My b, there's nothing put here. But what is the additive identity?
1. 0.
0, right? What was my y-intercept?
0, 0.
0, 0. So you can make a table, or you can just pay attention to the y-intercept and the slope. There's my y-intercept, there's my slope, there's my line. Multiple ways to approach it, you have to find one that works for you. Because this is what, one of the things that's frustrating me a lot, is that students are still saying, Mr. Kinney, I don't know how to graph this, which either means that you just didn't try it before, you didn't learn it when I've seen you do it multiple times before, or you're really not trying the homework.
I just forgot to do it for a second.
Well, we need to keep practicing with it. You'll have some more homework with it tonight. But again, that's why I have tutoring Monday, Wednesday, Friday morning. If you have questions on homework and it's a Monday, Wednesday, Friday, just walk up here before the bell rings. I'm here. Okay? Now, when I look at this first one though, y equals 3x minus 2, again, what form of a line is this?
Y equals mx plus 9. I'm just kidding.
mx plus b? So what's my rate of change?
B.
Why would b be the rate of change? Is that happening one time or is it happening
MX,
multiple
I'm
times?
sorry, mx.
mx is the rate of change?
Yes.
Not the whole thing. X is a variable. X is something that's changing.
Yes.
M is my rate of change. Remember, Peyton, what's happening between the 3 and the x? They're being,
Multiply.
and that multiplication is repeated
Addition.
addition. That's what we want to pay attention to here. I'm multiplying by 3, so I'm repeatedly adding 3. Which also remember, slope is rise divided by, so 3 divided by 1. Notice, that's my
You're
rate
not-
of change.
Wait, you're repeatedly multiplying 2 for number 2.
What?
Oh, never mind. I was looking at the wrong problem.
Okay. There's my slope though, and that's my rate of change, but where am I starting at? What is my y-intercept?
-2.
Right? So I go to the y-axis, I go down to -2. And then I rise up 3, and I run to the
1.
right 1. Rise up 3 to the right 1. Up 3 to the right 1. You can also go down 1, 2, 3 to the left 1. Notice that keeps it in line. Down 1, 2, 3 to the left 1. We talked about that as well. Using your slope, using your y-intercept is a very valid way to find those points accurately. Desiree, helps keep your head up, and you have to keep your mask on. But I do want to remind you, can you use a table here? What x value did I say I recommend plugging in first? And then I usually do 1 and 2, -1 and -2. What is 3 times -2 minus 2? Notice I'm just plugging my x in.
4.
Not 4. What's 3 times -2?
-6.
Minus 2.
4. -4. What?
It's going to get more negative.
Oh,
my.
-8.
Okay? -2, 1, 2, 3, 4, 5, 6, 7, 8. Is that a point on the line?
Yep.
That I more easily found just by doing the y-intercept and the slope? Yeah. But you can plug these numbers in. What's 3 times -1?
-3.
-3 minus 2.
-5.
So -1, 1, 2, 3, 4, 5. There it is. What about if I plug in a 0?
It's gonna be 1. It's gonna be -2.
0 minus 2
Where is it?
-2. 3 times 1
3.
minus 2.
1.
3 times 2
6.
minus 2.
4.
Notice, what is my y-intercept?
0 to -2.
There's that -2 again. What am I repeatedly adding?
You're 2. you're repeatedly adding,
3.
31, -1, 3.
Oh my gosh.
I'm adding 3, aren't I?
Yes.
Notice the idea of repeated addition is again why we have multiplication here. You multiply by the slope. These are things we want to see connections with. Right? Once I get my points though, notice again, and if you did not know this, then I would write a note down here of to graph the line. And this is, you just need a quick summary of what you could do. 1, ID, slope, and y-intercept. Right? You need to identify those two things in order to be able to graph the line. That's the quicker method, but is that the only way to do it?
No.
No. Or 2, create a table and plug in x values to get y values. That's it. That's all you have to do. These are things that we've covered since the beginning of the school year. If you had me or Miss Anderson, you've covered it since last school year. These are things we've got to know how to do. Okay? Now, I'm not going to cover all of 2 again because we did so much with number 1, but I do want to point this out. Where do these two lines intersect?
At,
1, 1.
yes.
And notice here, if I plug 1, 1 in, well, it makes that equation true. Does it make this equation true?
Yeah.
And you cannot forget this detail. Every point on this blue line makes the blue equation true. That's why it is graphed, and that's why we connect the points. Even this point right here that I don't have an actual point at, that point right there, guess what that point does to this equation? Makes the equation true. There we go. Every point on this red line makes the red equation. So then this point of intersection right here, where both of those lines are intersecting, that one point makes both of them true. Notice we can even verify it right here. When I plugged it in, did it make both equations true? That is the point of a point of intersection, that it makes both equations true.
Yep.
Any questions about that before we move on? Do we understand a little bit better about how to graph a line from an equation? I need you to understand, guys, I'm not just trying to, first off, do I make you do this every single day in class and just like beat your head against the wall trying to do this?
Yes.
No.
In class?
No.
Yes.
Oh, yes.
In class.
Everybody agree with that.
Look at the beginning of 5.1.
I'm looking at it.
Beginning of it. How many graphs do you see there?
A lot.
You're a liar. How many equations do you see there?
78.
What was your
3,
on
7,
There's
4,
none
2.
there. Guys, here's the thing I want you to understand. I need y'all to practice these things, but I'm trying to make sure in class that we're looking at math a different way than just beating our head against the wall trying to do this. But these are things, like if it's this thing on homework, it is something that I know that you are capable of doing because we've done it before. I'm not assigning you stuff on homework that is brand new information. That's what the set section is, which is why I don't assign it for homework. The ready and the go are things that you should know. And if you don't, that's a red flag, and you should be like, man, I need to ask some questions, or I need to come into tutoring, or I need to go search on Khan Academy. Remember, there's literally a topic right here that will give you helpful information about how to do this. You got to put in the work. You got to be ready for class. Here's numbers 8 and 9. We're not going to spend a ton of time here because we have already spent more than enough on the number 1. Any guesses about, maybe how I graphed these equations? Or a way that you could for tonight's homework, since tonight we'll have an accuracy check tomorrow.
Make a table.
You can make a table, right? What are some good x values to plug in when it comes to doing a line? Those are good x values to plug in? 1, but that's not where I would start.
0.
0 would be good.
And then 1, 2, and then -1.
Now I will say, and this is an important detail to notice on number 9, I would not do 0, 1, 2, negative 1, negative 2. Because we got a fraction here, right?
Yeah.
What are we dividing by?
3.
So I'm going to use multiples of 3. So instead of using 1, I might use a 3, then a,
6. 9. Let me move 3.
and you could use the 9, but those are the things I would be thinking about. This also connects to a really important idea. If it's y equals mx plus b, what is this 1/3 right here? What is m though? No, what do we mean by m? Well, multiplication is repeated addition, but what do we call the additive rate of change?
Slope.
Slope, right? And if you look at a graph, how do we calculate slope?
Rise or run?
So notice how I'm rising 1, running 3. Hey look, I'm going by 3s on my run. Because the run is the horizontal, the x-axis. We all get with that idea? So you can make a table, you could use I would personally recommend doing the slope and the y-intercept, it's easier, but you can always make a table as well. The point of this though, and this is something we should recognize, right here I found the point 3, 5. Because that point is on the line, is it a solution? Remember, every point on the line makes the equation true, and things that make the equation or make the inequality true are solutions, right? If I look over here though, I've got the point 3, 5 is up here. So is 3, 5 a solution? No, because it's not on the line. Again, you're going to have some homework problems off that, so make sure you know how to do it. And it does ask you to find 2 more points other than 3, 5. Notice any point on this line makes the equation true. Any point on this line makes the equation true. Alright, let's get started with today. So we got our objectives as normal, and then after our objectives, we're going to relaunch 5.1 to make sure we're all on the same boat. We understand what we're doing, or what we're recapping what we talked about yesterday, and then you'll work in your groups for the rest of the period. Devin, can you read our first objective for us today? Are you on this word? Constraints. Okay, so don't forget, like when we say constraints, those are the limitations of a word problem. When we talked about Carlos and Clarita yesterday, could they just house however many cats and dogs they wanted? No. Why not?
Because they'd be considered crazy.
They don't have that much space or money.
They didn't have enough space or square feet, and they didn't have enough budget, right? They only had about $1,000 to spend on buying cat pens and dog runs, which I was talking about with the classes earlier today. To be real, if I had $1,000 as a high school student, I don't think I'd spend it like that. Would you?
No.
Probably not, right? I know Shelby could go buy a couple fishing poles or something, but I don't know about the rest of you, huh? You best believe it, right? But here's the thing, like this is a legitimate detail that we're going to look at today. Is it worth it for them to spend the money? These are questions that you need to ask, and you need to investigate the numbers more heavily when it comes to your actual life as well. Because legitimately, when I think about it, I'm like, man, if I was a high school student, would I have spent over $1,000 getting this business going? The answer is no. But then I start looking at this problem, I'm like, man, if I had paid attention to the numbers I might have. And we'll do that in just a second, right? So we need to find values that satisfy the constraints, the limitations. But this, again, is the most important part. And this is the part that students again and again ignore me on. Desiree, can you read the second objective for me?
How you get multiple mathematical representations to model values that satisfy the constraints of a word problem?
There are so many ways to represent mathematics. However, just writing randomly is not one of those ways. Plugging stuff into a calculator is not one of those ways. Because you can do those things, but you're never simplifying or making your process faster. If we are following mathematical representations, what we're going to find is ways to speed our life up. What are the mathematical representations that you can create to understand the math better? Tables, graphs, what else? Pictures. Pictorial representations or pictures. Think about it. I mean, like, we're looking at it here, but could you draw out their shed and look at the space that's available? Like, you can do that, right? So we got pictorial, we've got tabular, and graphical. What else?
Verbal.
Verbal, right? You could use your words to describe what you think is happening. What else? An algebraic. Guys, this is an algebra course. I know that I'm telling you not to jump straight to an algebraic expression. However, I keep seeing students do the same thing over and over and over again, and they keep reworking it the whole time instead of just saying, hey, there's an expression here. If something stays the same, that's going to be a coefficient or going to be a constant. If something is going to change an expression, that's going to be a variable. Pay attention to the representations you're creating. See if there's a pattern with the table. See if there's a pattern when it comes to the graphing of the points. Those are things I want you to pay attention to. Okay? So we have two different contexts going on here, right? Or two different constraints. We talked about already, the space and the startup cost. So let's pick back up at least with one group's set of points. Peyton, where did y'all leave off yesterday? What number of cats and dogs were y'all looking at?
Oh, we all had different ideas on what we thought we should do.
But you're one group. Why weren't y'all working together?
Well, what I thought would be
We
best
can
would
work
be
together.
get our own idea and then see if our own ideas matched, and they did not. But we didn't get to talk about our ideas because we ran out of time.
Okay.
I know.
So
that we,
this would be a reason why we might want to be sticking together. If you have different ideas, test out those ideas together, right?
That's what we were gonna do, but we ran out of time. What I was thinking was we all get each a different idea, just see if we all got the same idea, and then talk about ideas that they're different, which we all did get a different idea, but we did not have time to talk about them.
Okay. But what I'm saying is, if you started with a different idea, follow each person's idea together, right? So maybe you start with Peyton's idea, then you move into Kelsey's idea, and so on, right? Work together though, because then you can discuss those ideas a little bit more heavily and a little bit better. Shelby, what about y'all? Did y'all come up with a number of cats and dogs?
We had 11 dogs and 12 cats.
Okay, so 11 dogs and 12 cats. Now we need to recognize, right, that we have to consider two different things. What are those two things we need to consider?
Age and investment cost.
Right? Space and cost. And really there's a third thing. How much money you're going to make off of it, right? So space-wise, how did you figure out how much space these 11 dogs and 12 cats were going to take up?
12 times 32, which was the cats.
That was for your space?
Wait, no, that was for 12 times 6 was space.
Okay, so 6 square feet per cat. So 6 times 12.
And then 11 times 24 for the dogs.
Okay? And so what did that come out to be?
336.
Notice I'm not even taking the time to show the work for this, because can't you just plug all that into the calculator at the same time? But I'm showing where that 336 came from, because isn't this an expression right here? Maybe if you paid attention to your expressions and paid attention to what's staying the same and changing, you could create an algebraic expression with variables in there. But thank you for doing that, Peyton. What about cost?
We did 12 times 32 for the cats and 11 times 80 for the dogs.
Okay, so and so what did that come out to be for the cost?
1,264.
So at least for those, are we satisfying the space constraints and the cost constraints? Okay? And so once we do that, we might want to think about, okay, so how much money is that going to be? First off, before I move into this, does anyone have any questions how Shelby came up with these numbers? Of 6 times 12, 24 times 11, 32 times 12, and 80 times 11. We know where those are coming from? Because remember, you have to work on those within your groups. Okay, so how much money would these 11 dogs and 12 cats get us?
$316.
Okay, how'd you get that though?
I don't really remember. I forgot to write that part down, and I don't remember
How much are you making from each dog?
Hey.
That's how much you're paying to build the dog run. Making $20 per Dog, right? So
times 11,
20 times 11.
and then it's 12 times 6.
How much are you charging for the cats?
I mean 8, my fault. 8.
Okay, so 8 times 12 cats came out to be $316, right? So that's 11 dogs and 12 cats. That's just one option. Your job is to figure out, hey, who's going to make the most money? Notice, and you don't have to do exactly this way, and there's actually other things I would probably do, but notice I have a space for my space and a space for my cost, and I'm able to keep track of these things at the same time, right? Maybe I write 11 dogs and 12 cats off to the side over here, but then I do my space for space and cost, right? I'm trying to organize my information so I can come back to it and pay attention to it later and understand exactly what this looks like. And I can use it as I study. Alright, so let's go ahead and get back to working within our groups. And we have the rest of the period to learn. But remember, it takes talking and discussing with each other.